All right, good morning. Happy Wednesday. Today we're going to talk about spheres. Spheres. Three-dimensional circle. We'll kind of ignore this little piece at the top. We could say it's like a sphere and a cylinder, but sphere. Perfect circle. So we kind of talked about these before the break. We have circles that can go all the way around. Anyway, I slice this, I'll get a circle. But the great circle goes at the widest part of the circle. So that'd be like our equator or the prime meridian, or I could do it like at a diagonal. But if I cut it, slice it here, it's not going to be as big as that great circle. So when we're talking about the radius of a sphere, you have to go from the very center to the edge. You can go to any edge, but it's going to be like from the center inside to the outside edge for the sphere. So let's look at the surface area and volume. All right, so a few definitions. So a sphere is a set of all points in space, so three-dimensional spaces. Sorry, Stephen, only 3 dimensions, but they're equidistant from a given point. So I have some center point, and then my radius goes in all 3 dimensions all the way around to give me my circle. When we draw circles, a piece of paper, when we draw spheres, we draw a circle. I put the center in there, and then we make what I like to think of as like a smiley face, and then a frowny, ooh, not the best, frowny face here to kind of show that this is my great circle that kind of goes through the center. All right, so the center is the given point in the center of the sphere. So we have a radius, which is from the center of a sphere to any point on the sphere. And then chord versus a diameter. So a chord is any line segment that connects from an edge to an edge but doesn't go through the center. And then the diameter, like a circle, goes all the way through. So it represents 2 radii. All right, so we have the surface area and the volume formula for a sphere. They're very similar, but just be careful with your numbers. So surface area, which is the outside edge, is 4 pi r squared. So my area is always area or length squared. And then my volume is 4/3 pi r cubed. So it's like the 4 from the surface area, and then the 1/3 from the cone and the pyramid. But we put them together, 4/3 pi r cubed. So 3 dimensions, length times width times height. So spheres are pretty easy to find, the surface area and the volume. So we like to give you extra information and have you find let the surface area or the volume, maybe one from the other, all that good stuff. So I've got 4 examples here that we're going to work together. So let me zoom in. So first, we want to find the surface area of the sphere. I'm going to find the surface area and the volume just for good practice. All right, so for the surface area, we have 4 pi r squared. And in this figure, my printer, my radius is 9 inches. So my surface area is 4 pi times 9 squared. Let's just type that into the calculator. So 4 pi and then 9 squared is going to give me 324 pi. Please leave the pi unless you are told otherwise. So surface area, 324 pi, and then I had inches, so my unit here will be inches squared for the surface area. So that's the amount of fabric that we need to cover the sphere. All right, and then for the volume to go inside, we have 4/3 pi r cubed for the volume. Same radius, so I have 4/3 pi times my radius 9 to the 3rd power. So, let's see, 4/3 times pi, and then 9 raised to the 3rd power. So I end up with 972 pi as the volume, the amount that goes inside. 972 pi. When you're dealing with the fraction, 4/3, sometimes you'll get a decimal with this. Just round it to 2 decimal places if you have a 0.3 or a 0.67. All right, so here, letter B, I want to find, I'm told that the surface area is 12.25 pi. I want to find the diameter and volume. So I'm given the surface area. So these are the kind of problems where we're going to work backwards. You'll see quite a few of these. So the number that I'm given is the surface area. So the surface area is equal to 4 pi r squared. What I don't know is the radius. I can find it because I know the surface area. So 12.25 is equal to 4, oops, so sorry, I missed my pi. Let me start fresh. 12.25 pi is equal to 4 pi times the radius squared. So I need to solve for the radius. So I need to divide by 4 and pi. I'm going to go ahead and do those at the exact same time. So divided by 4 pi. Now be careful in the calculator. If I type in 12.25 pi divided by 4 pi, this is only dividing the pi by 4 and not the 12.25 in the dividing by pi. So just dividing what it's touching. So I highly recommend that you actually use a fraction. 12.25 pi on top, 4 pi on bottom, or we could also notice that they have pi's on top and the bottom. Either way, we're going to get 3.0625. Leave all your decimals for these kind of problems until the very, very end. So 3.0625 is equal to my radius squared. How do we unsquare a number? That's right, I square root it. So I need the square root of 3.0625. So here's why it's important to have all the decimals, because when I square root it, it should come out to be a pretty decent number. So the square root of 3.0625 is 1.75. So this is my radius. This is my radius when I solve for r. So r is equal to 1.75, then I'll stick my unit of centimeters. So I haven't answered the questions yet, but I'm pretty close. So the diameter is 2 radius put together. So it's 2 times 1.75 centimeters. So that's going to end at being a diameter of 3.5 centimeters. Right? And then I'm going to go and find the volume of the sphere. Since I know the radius, shouldn't be too bad. So my volume is equal to 4 thirds pi r cubed. So my radius I found to be 1.75 to the third. This is probably going to give me some crazy decimals since I have a decimal and have a 4 thirds. Let's just plug it in. So 4 thirds pi times my radius, raising it to the third power. And I get this weird decimal here. So let me try this again without the pi, and then I'll just stick a pi symbol at the end. So it still has a decimal because I'm raising a decimal to the third power and then multiplying it by a fraction. So I'm going to put both answers down. So I like the 7.15 pi centimeters cubed as an answer. But we can also, I missed it up here, 22.45 centimeters cubed. All right, so if you have crazy decimals, with the pi, without the pi, you can solve it either way. All right, you're going to see some of these problems. All right, so here I have another problem with a bowling ball. Any bowlers out in the crowd today? So we have a diameter of the bowling ball as 8 inches. So I want to find the volume. So my radius of this bowling ball is half the diameter. So that's going to be 4 inches. So my volume is going to be equal to 4 thirds pi r cubed. And my radius is 4. So I'm going to type this into my calculator. My 4 thirds pi times my radius cubed. So I got this crazy looking fraction here because it's dividing by 3. So the fraction is nice, 256 pi over 3 inches cubed. I can do that same problem without the pi symbol, and I can put the pi at the end. So 256 over 3 pi inches cubed. These are actually identical because you can put the pi in the numerator or the denominator. I can find the decimal approximation for this. So 85.33 pi inches cubed. Any of these will work. I'll be honest, I like it coming straight out of the calculator. It's the most concise, it's in there, but any of these, oh my 5, any of these will work as an answer. All right, I have one more example with spheres. So I'm finding the radius of a sphere when I have this given volume. So kind of like the one we did here where I had to find the radius from the surface area. Okay, there it goes. I'm going to find the radius from the volume. So volume is equal to 4/3 pi r cubed. This is a really good example to have in your notes. So if you want to pause, you can write this problem down and then have it as we work it out. Really good problem here. So I'm looking for the radius, and my volume is 1436.76. And that equals 4/3 pi r cubed. So I don't see a pi over here, so it's already been like multiplied by 3.14. So let's go ahead and get rid of the pi first. So I'm going to divide both sides by pi. I'm not going to divide by the 4/3 just yet because that gets a little bit messy. But in my calculator, I'm going to do 1436.76 divided by, and I'm going to use the pi button. And I'm going to write all these decimals down. I don't want to round until the very end of my problem. So I'm going to write down all these decimals. So this is 457.3349121. And this equals 4/3, nope, no pi, just r cubed. All right, this fraction can be eliminated by multiplying by its reciprocal. So I multiply by 3/4, and then this side by 3/4. My 4/3 times 3/4 disappears. So whenever you have a fraction, it's nice to multiply by its reciprocal to both sides to get it to cancel out. So this is going to be equal to my r cubed value. So I'm just going to take this, it's already in there, so I'm going to multiply it by 3/4. Another nice thing about these calculators, like you don't have to type the number back in again, you can just say the last answer, or I can copy the number down there. Here is my radius cubed. Again, I want to keep all the decimals until the very end. So 343.0011841. All right, so how do I uncube something? Well, I unsquared something by square rooting, so I can uncube something by cube rooting. So I'm going to take the cube root of both sides. So I'm looking to see what to the 3rd power gives me 343. On your calculator, you actually have a button that will do a cube root. So above the x squared, we'll do a square root. Above the x with the whatever power, we'll do a whatever root that you want. So if I hit second and then that x with the box, I can come back over here and I can change this and make it the cube root. All right, so I'm looking to see what to the 3rd power gives me this number. And then I'm just going to grab this number here and it'll give me the cube root. This is the cube root of 343.0011841. Now, I'm going to round to 2 decimal places, so I'm going to say that my radius is 7. And then my unit of measure is meters. So I like to make sure when I'm doing these kind of problems that I did get the problem right. So I'm going to take my radius of 7 and say 4/3 times pi times my radius of 7 raised to the 3rd and see if I get this decimal number. I got 1,372 pi over 3. Remember this button right above the equals, I can show it to you, will give you like decimal approximations. So I'm going to hit that button and it is pretty close. So they rounded this to get the 0.76. So my radius is 7. Guess and check works for these two, but you might be guessing and checking for a while, especially if it didn't come out to be a whole number. All right, surface area and volume of spheres. Your assignment for today is going to be in this packet again, dealing with the spheres. So we're looking at pages 6 and 7. Pages 6 and 7, and we've got some composite stuff going on in there, and then we're going to look at some composites tomorrow. All right, have a great day.